Welcome to our in-depth tutorial on creating the layout of basic logic gates using Microwind. The experiment used in this tutorial is from JNTUH curriculum of ECE 3rd year 2nd semester CMOS VLSI design lab. The aim of this tutorial is to understand the process of laying out basic logic gates using Microwind. After layout, we will see the simulation results to verify the functionality and calculate electrical parameters such as power consumption and operating frequency. So let's begin. To begin, ensure you have Microwind software installed on your computer. Our design procedure starts with launching Microwind. Upon opening, you'll see a black background which represents N-type substrate. First, find and click on the Compile tab located at the top menu bar. This is where our design process begins. Under Compile, you'll see an option named Compile One Line. Click on it. A list appears, showcasing different logic gate equations. For our tutorial, let's select the AND gate as an example. Click on the equation corresponding to the AND gate. This action instructs Microwind to prepare for designing this particular gate. After selecting the AND gate, hit the Compile button. This doesn't immediately show us any waveforms because, at this stage, we are essentially creating the blueprint for our gate without specifying how it's tested. Look for the Show Palette button. This tool allows us to introduce inputs and outputs into our design. Click on it. We need to simulate how our gate reacts to changes over time. Let's add a clock. Click on Add a Clock, then click near where the A input is supposed to be. A dialog box appears. Name this input A_in and set it to the standard frequency. Repeat the process for the B input but adjust the clock to ensure it doesn't transition at the same time as A. Name it B_in. Now, for the output. Select Visible Node from the palette, click on the output area of our design and name it out. Then click Assign. This action prepares Microwind to show us how the output reacts during simulation. Run simulation. If the waveform blends too much with the background, making it hard to see, don't worry. You can adjust the background color. Close the simulation window, navigate to File Colors, and choose a contrast that makes our waveform pop. Run the simulation to view the waveform. Adjust the time scale for a more detailed view if necessary. Reset the simulation as needed to observe the waveform under different conditions, noting that the output is high only when both inputs are high. To analyze voltages and currents, go to the Voltage and Current tab. Click on Reset to view the current flow and voltage swing under various conditions. Examine the frequency versus time to observe changes in frequency levels throughout the simulation. Use the FFT model to analyze the output voltage at significant frequencies. Record the average power consumption as indicated by the simulation. As we wrap up this tutorial, remember to save your file for future reference. We can repeat the same procedure for implementing other gates such as OR gate and NOT gate. We can choose to implement the new gate in the same file. In such a case, the newly implemented gate will get fused with the existing design. For now, you may consider implementing the new gate in new file. Thank you for joining this tutorial. Explore, experiment, and expand your knowledge. For more detailed guides and resources, don't forget to visit our website https:// www.research1.fun, listed in the description below. The webpage contains lab reports and Viva questions for practice. If you found this tutorial helpful, like, share, and subscribe for more content. Until next time, happy designing.